Yes, welcome class. Welcome to the session. Today we will get into the second part of our chapter on inspection and quality control, that is control charts or statistical process control. Now, these control charts are normally adopted by softwares where you feed in the data and the software automatically generates the charts for you. But exactly how it is drawn and what purpose it serves must be clear to all of us. So let us begin with the first slide. I hope the slide is with all of you. The slide and the handout that I had provided is with all of you. So, as per the first slide, there are broad categories of control charts for variables and control charts for attributes. Control chart for variable indicates the control activities performed on the quality of the process, whether there is any deviation in the process quality is control chart for variables, whereas attributes are defectives or percent defectives or number of defectives per lot is counted as control chart for attributes. I'll just read out two definitions. It'll be easier for you to understand. The chart which depends on measurement of quality feature is known as control chart for variables. The control chart for variable are cheaper than control chart based on attributes. The most frequently used variable control charts are xbar chart or R chart or sigma chart. These are some of the control charts that you have for variables. The most important of them is xbar chart and R chart, of course. We will later on solve a problem also on xbar chart. We will see how a problem is solved. Whereas control chart for attributes, it says it is the nature of product if the nature of product does not allow the quality characteristics to be measured in quantitative terms, then the products are divided into defective and non-defective when the final inspection is done. The defective in that item can depend on number of factors, and a separate record can be made can of each cause can be made. Now see, if quantitatively you cannot judge the level of quality, how good or how bad the product is, if you cannot quantitatively judge, then you have to find out whether the product is defective or non-defective, the attribute based, and if defective, how many defectives are there. So for them there are various charts available: N chart, NP chart, C chart. All these charts are available, but most important is control chart for variable and control chart for X bar. Okay, so let us move on. The next slide gives us X bar chart, and the formula for X bar chart, the first thing you can see is X bar is equal to summation of x1 up to xn divided by n. That is the X bar of each sample, X bar of each sample, and X double bar is summation of all X bar up to k. That is, there are k number of groups. It is assumed that there are k number of groups or k number of samples that you have chosen, or k times you have chosen the samples. That is X double bar. Now this X double bar becomes your control line. Control line. As we will proceed through the slides, you will understand that what is control line and what is upper control limit and what is lower control limit. If this is my chart, when through this passes my control line, this control line is x double bar, and there is an upper control line called UCL, there is lower control line called LCL. If points, if products manufactured are all inside the upper control and lower control line, the product is said to be, or the process is said to be under control. Whereas if any of the deviations takes place, then it is said out of control. We will see in the next example. You can see in the next example of X bar chart that so many points are there, and each point a line graph has been drawn, and all points are within the upper and the lower control limit. In the next example, you will see that one point, although all the points are inside control and very much close to the control line, one point is just outside the control. Now, how many points are here? There's a general question that if one point is out of control, do we call it out of control? The entire process out of control? Normally, yes, because see, how many points are here in this example? In this example, if you focus on this example, you will find that see, all the points, approximately all the points are very close to the control line. All the points. Just one point here, over here, is out of control, is crossing the UCL, Now you will say that if so many points are in control and just one point is out of control, do we say the process is out of control? Yes. Why? Because how many points are here? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 points are here. 12 points are here means, let us say we are dealing with 10 points. Now, in this 10 points, 1 point is out of control means 10% of the product is out of control. 1 point out of 12 point or 10 points means approximately 10% product is out of control. Now, if 10% of product is out of control, it is a huge thing. It is not a joke. If a 10% if you are sending products into the market with 90% accuracy level or 90% control level at the 10% faulty products, then every 10 people purchasing will have a faulty product, and that is going to crash your goodwill, your any faith the consumer has on you will be crashed down if such thing happens. If out of 1,000, out of 10,000 people, one people comes up with a complaint, then it's okay. But if you're a good company and if you find that out of every 10 people, every 12 people, one people is having such a problem, then it is really a serious issue to be checked upon. Okay. Next, in the next example, we see, if you very closely look at this example, you will find if I stop here, this is also out of control. This is categorically out of control because I will had kept my observations till here. Would you have said the process is in control? You would have said the process is in control, but better inferences could have been made. Better inferences could have been made. What inferences could have been made? That the process is in control, true, but it is gradually going out of control. You see, the process is in control, true, but it is gradually going up. So, sooner or later, had you been blocked here, sooner or later it would have crossed. So, precautions must have been taken in some cases where you see a trend upward or a trend downward. So, this kind of control chart suggests that even though sometimes you will find the process is in control, still you have to understand or analyze the trend, the pattern. Is the pattern randomly uh, around the control line, or is the pattern going towards breaking the upper control line or towards breaking the lower control line? What kind of pattern is it? So based on that, you will have to infer the results. Plus, there are other inferences also. For example, I'll read out some important stuff. See, it says where R chart shows all the points within control limit. If R chart, range chart, shows all the points within control limits, then if in X bar chart the points lie beyond one of the control limit, it shows the process level has shifted. If R chart is okay, and if X bar chart only one point is, if X bar chart only one line, upper control line or lower control line, has been crossed by the points, not both, only on one side, either on upper side or on lower side, then you must know that the process control has shifted. If it has fluctuated on both the sides, with the range being the same, it means that random changes are taking place and frequent adjustment needs to be made. So this kind of interferences can be made from X bar R chart, and from every chart you can make such inferences. Okay, now let us get into the problem. The problem that are given to you had 10 samples, 10 number of samples, each of size 10, with each of having an X bar and each having a range. If you see the problem, not the PPTs, it's not the PPT any longer, it's the problem. So if you find the X bars and the R's, then you have to first find X double bar. X double bar is total of X bar by number of samples. That is 60.5 divided by 10 is equal to 6.05. Now, there is a constant value that is given from the table called A2 for developing X bar chart. That is, here it is 0.48. So X bar chart, the upper control limit of X bar chart is X bar plus A2 R bar. X double bar, it will be X double bar plus A2 R bar. And lower control limit is X double bar minus A2 R bar. So with these things, you will get 2 points. One is 7.78, one is 4.32. Now you will know that A2 will be given to you. The value of A2 will be given to you. Now, from where this value of A2 is coming? It is basically what we are doing is we are finding out 3 sigma on either side of the control limit. If the control limit is this, if this is my control line, this is my control line, plus 3 sigma plus 3 standard deviation is this, and minus 3 standard deviation is this. It's assuming it is a normal distribution. It's assuming it's just a normal distribution it is following, just an inverted normal distribution. If you just a normal distribution, if you invert the normal distribution, you will get this kind of a distribution where two lines are blocking. Two lines are creating upper and lower control limits of 3 sigma each. Now, since sigma's value is not available all the time, and these charts are normally operated by the ground level supervisors or workers, they are provided with this constant value called A2 always. And in case of range chart, R bar chart, it is always provided, they are always provided with the value of D3 and D4. For your general knowledge, we will say to make an R chart. R bar is your central line, D4 R bar is your upper control limit, and D3 R bar is your lower control limit. In this problem also you can see that D4 R bar is your upper control limit. At the slide that I have shown, that material that I have provided you, below that it is written, it is clearly written. X bar chart you can formulate like UCL is X bar plus A2 X double bar plus A2. I'll repeat the formula once again. UCL for X chart is X bar chart is X double bar plus A2 R bar, and the lower control limit is X double bar minus A2 into R bar. For R chart, R bar is the control line, D4 R bar, D4 into R bar is the upper control limit, and D3 into R bar is the lower control limit. If you had a board, it would have been better to explain. So I hope you have understood with the help of the explanations given here and in the slides. This is the concept of control charts. Prepare yourself very thoroughly with X bar chart because it's the most important chart. Okay? Thank you, class. Thank you for your patience.